This clip will talk about normal distributions a little bit as an introduction. Piles of data can be put into a mathematical model called a normal distribution. Large data sets like the SAT tests and the IQ tests fit nicely into this kind of a distribution. For example, the SAT reading portion has an average of 500 and a standard deviation of 100. As it turns out, as this pile suggests, most of the data is clustered right around the center. As a matter of fact, statisticians know that 34% of the data falls between 400, or one standard deviation below the mean, to 600, 400 to 500, and then another 34% fall between 500 and 600. So about 2/3 of the data falls in here between 400 and 600. As you can see, it starts to taper off as you go farther away, and this turns out to be only 13.5% in each of these little slices. And then we can probably calculate, since we know about 50% is below and 50% is above, if you actually added this up and took it away from 50%, you'd see that 2.5% would be in each of these tails. And so this pattern is very predictable, and so we can, as a result, do some estimations. For example, if I wanted to say what percentage of the people that test below 600. Well, 600 is here. This, by the way, is 3, and this is 700. So 600 is here, so there's 34% here. But then we know from 500 down is half of the distribution is going to be over here. So that's 50%, plus the 34% is 84% of the population should be below 600. You might say, well, what percentage tests above 600? The same number. Well, if 84% is below, we know that the total has to be 100%. So that would mean that 16% test above. You can ask other questions. What percent would you estimate test between 400 and 600? Well, again, we start at 400, and there's 34% here, and then from 500 to 600 is another 34%. So we can actually add these two together and get 68%. So you can see that this is almost like a jigsaw puzzle where I can take little chunks out of this graph and use logic to estimate what percentage is between one score and another. So for example, if I wanted to say how many are between 400 and 700, I won't do all the calculation here, but it would be just this chunk plus this chunk plus this chunk. Just add them all up, and that is what percent, that is the percentage that would be between 400 and 700. So there's a whole set of logic questions that you could enter into related to this normal distribution. The IQ test is very similar. It has a mean of 100 and a standard deviation of 15. The only thing that changes, the graph looks exactly the same. It's just these little benchmarks are a little different. Instead of going from 500 to 600, this 15 is the standard deviation, so one standard deviation to the right of the mean is 115. One standard deviation below the mean is 85. So the increments change, but the mathematics stays exactly the same. So we can ask questions, for example, what percent of the people have IQs above 85? Again, half of the curve is from 100 over, so that's 50%, and we know that 34% is in here between the mean and one standard deviation. So again, this is 84%. And so the same logic questions, so that's 50% over here. So the same types of logic questions can be asked back and forth between the SAT and the IQ. Now, for what do you do for numbers in between the even demarcations that you see here? Well, you actually have to either use a table or a computer program to do those calculations. Fortunately, in Excel, there are two wonderful little mini programs. One is called NormDist, and you can find it in Excel by inserting the function NormDist. And this program, you tell it what score you want to check for, and you give it the mean and the standard deviation. Also, you always answer true to the cumulative question. I won't get into it other than to just say whenever they ask you is the cumulative, you say true. And it spits out the proportion of the people to the left of that score. So, for example, if I punched in 600 for the score and 500 for the mean and 100 for the standard deviation. Let me slide this up so you can see what I'm writing. Okay, so I plug in the score of 600, the mean is 500, standard deviation is 100, and I put true for the cumulative question. It's going to tell me what percentage of people are below 600. Well, we asked that question earlier, what percentage? I'm going to get a number that's about 84%. It's going to be in a decimal, but it's going to be approximately 0.84. The nice thing about this program is now I don't have to put all the even numbers that are here, that are in the chart here. I can actually put in a score of 640. So I've got my computer up. I'm going to punch in a score of 640, a mean of 500, a standard deviation of 100, true, and I'm going to see what that number is. We would expect, since it's 640, it's a little bit larger than 600. It's not going to be 84%, and this would actually be 97.5 when we go all the way over here. We would expect somewhere between 84 and 97%. I'm going to go over to my computer and go into Excel. Should have had this up, sorry. I'm going to go over to Excel, and I'm going to hit the little button for NormDist. It asked me for the score at 640. It asked me for the mean, 500. It asked me for the standard deviation. I punched that in. It asked me the question whether it's cumulative. I say true. And our answer actually comes back as 0.919. Or in other words, 92% of the people score below 640 on the SAT reading. So if any of you scored above 640, congratulations. You tested higher than 92% of the people taking the test. The second little subroutine that Excel can do is the other way around. When we, it's called NormInv, and it's when we know how many people or what percentage of people are below a particular score, and we're trying to find what the score actually is. So in this one, we put a p-value. That's sort of the proportion of people below a particular score. Suppose I wanted to find out the score for the top 10% of the people who took the test. It's actually pretty close to this number, but if I wanted to actually find out what is the score that actually is the dividing line for the top 10%. Notice I'm putting in P equals 0.90 because that would mean 90% test below that particular score. I actually also put in the mean, same mean, and the same standard deviation, and I'm going to see what score Excel gives me. So I'm back over to Excel. I am looking for the function norminv, INV. As soon as I put it in, it says probability. I'm going to put 0.90. It says the mean, that's going to be 500. The standard deviation is 100. And it tells me that the exact score, theoretically, is 628. Well, I don't think any of us have ever taken the SAT and gotten a 628. So it's pretty safe to say that the cutoff is 630. If you have 630 or more, you're in the top 10%. If you're 620 or less, you're below the top 10%. So these are the two routines that are in Excel that are really helpful. You can also find online little online calculators that will do the same kind of calculations for you. Remember that normdist and norminv deal with the area to the left of a particular score. So the earlier one we did 600, and it's going to always tell us the area to the left. So that's good. So no matter what, we always know that it's dealing with the area to the left. So when it spits out an answer of 0.84, that's 84% of the data is to the left, or the probability is 0.84 of being less than 600. That also implies that the probability of being above that is 16%. Okay, and the same thing is true down here. The only difference here is I actually put in the percent or the probability. So I want to find the cutoff for the top 10%. So in other words, I want the lower 90% because the top 10% is right here. So that means the rest of them are down here. It's 90%. I put in 0.90 for P, 500 for the mean, standard deviation of 100. It comes back as 628. So we recognize that there's no such thing as a 628 on the SAT. So everybody that scores 630 or above is actually in the top 10%. Okay, thank you very much. Have a good day.